you Mariah. Shawty look good in the moonlight. Spotlight, moonlight. Nigga, why you tripping? Get you Mariah. Shawty look good in the moonlight. All this pussy niggas so bad, my
Fall protection systems. Let's look at some component definitions. We'll begin with the ABCs of active fall protection. That's anchors, body support, and connecting devices. We'll also look at deceleration devices, so it's more like the ABCDs of fall protection. Our first term is anchors. Anchors are a secure point of attachment for equipment such as lifelines, lanyards, and deceleration devices. Anchors can be permanent or temporary, and how you select them will often depend on the type of job or task you'll be doing. Next up is body support. Body support options can be divided into two categories. These are body harnesses and body belts, both of which have different applications. A body harness is a piece of equipment that is comprised of straps that secure you in a way that will distribute force caused by a fall across your body and allows you to connect to other components in your fall protection system. A body belt is a strap that secures around your waist and is used to attach to other components such as a lanyard. Its use is more limited than a body harness and is only allowed in a positioning system or travel restraint systems. Next up are connecting devices. A connecting device is used to connect parts of a personal fall protection system together. Common examples include lanyards, snap hooks, D-rings, and carabiners. Let's define these terms. A lanyard is used to connect to a body belt, body harness, deceleration device, lifeline, or anchorage. It is comprised of a flexible line of rope, wire rope, or strap that usually has other connectors at each end. Snap hooks have a hook-shaped body, normally with a closed gate or something similar that can be opened to hook to an object. After it is released, the snap hook gate will automatically close to clutch the object. A carabiner, on the other hand, has a trapezoid or oval-shaped body with a closed gate, or something similar that can be opened to attach to another object. Just like the snap hook, it has to automatically close to clutch the object. Keep in mind that even though something is auto-locking, it's always good practice to double-check. It's important to note that not all carabiners are appropriate for your fall protection system, since they must be auto-locking, require at least 2 separate and consecutive movements to open, and be capable of withstanding 5,000 pounds of force. This means they meet the ANSI Z359 requirements. The final component we will be defining in this video are deceleration devices. A deceleration device is a mechanism that dissipates a substantial amount of force during a fall. Common examples include ripstitch lanyards, also known as shock absorbers or shock packs, self-retracting lifelines, and rope grabs. Let's briefly cover what each of these mean. A rope grab travels along a vertical lifeline connected to anchors. When a fall occurs, the rope grab automatically engages and locks to arrest the fall. SRLs, sometimes called yo-yos, can be described as a drum-wound line that can be slowly extracted or retracted when the drum is under slight tension during normal movement by the employee. If a fall occurs, the device automatically locks and the drum arrests the fall. Shock absorbers deploy when a fall occurs. The stitching rips, which absorbs a substantial amount of force that has been created, softening the blow.
We talked about the ABCDs of fall protection earlier. Let's recap what we talked about. A typical personal fall arrest system incorporates all of the following. Anchors are a secure point of attachment. Anchorage connectors vary by industry, job, type of installation, and structure. But some examples include structural steel members and precast concrete or wood trusses. Inappropriate anchors include fluid pipes, handrails, or electrical conduits. Suitable anchors must be able to support extreme forces generated in a fall. There are 2 anchorage classes considered for use in a fall arrest system: certified or engineered anchorages and non-certified or improvised anchorages. Non-certified anchorages must be capable of supporting at least 5,000 pounds per employee. But a certified anchorage must be designed, installed, used, and maintain a safety factor of at least 2, under the direction of a qualified person. Body support. Harnesses distribute fall forces over the upper thighs, pelvis, chest, and shoulders. They provide a connection point on the worker for the personal fall arrest system. When donning the full body harness, it must be adjusted to fit you properly. It should be snug, but comfortable. The sub-pelvic strap should be positioned directly under the buttocks. This strap and its proper placement are crucial. It is the sub-pelvic strap that distributes much of the energy generated in a fall to the structural part of your body. The chest strap must be fastened securely, and the dorsal D-ring should rest between your shoulder blades. Once your full body harness is properly fitted, you'll get freedom of movement, comfort, and maximum protection in a fall. Connectors, such as shock-absorbing lanyards or self-retracting lifelines, connect the worker's harness to the anchorage. Lanyards are made of rope, webbing, or cable, but when used for fall arrest, they must incorporate a shock absorber. Additional anchor connectors include snap hooks and carabiners. These are available in a wide variety of shapes and sizes, but all of them must be self-locking to reduce the possibility of a rollout or accidental disengagement. Although auto-locking snap hooks prevent rollout, they should still be coupled with much larger diameter hardware to prevent forced rollout. Forced rollout may occur when a snap hook is attached in a manner that enables the side of the gate to be forced open. To be safe, you always want to check with the manufacturers to make sure the connections you make are compatible. All snap hooks chosen for fall protection or rescue operation should be simple to operate to ensure they will be used correctly. They should have user-friendly, one-handed operation, even when wearing large gloves. Workers should always make sure they achieve positive connections between components of their personal fall arrest systems, especially when visual confirmation is not possible. For example, the attachment of a snap hook to a D-ring on the back of a harness. And as a general rule, all connecting components and assemblies must have a minimum strength of 5,000 pounds, even those used on shock-absorbing lanyards. Rescue and descent devices are used to lower an injured worker to the ground or retrieve him from a confined space. It is imperative to have a rescue plan in place at your job site in the event of an accident. And the plan must be reviewed and practiced on a regular basis. Calling 911 isn't enough. Your employees need to have the necessary tools, training, and skills to assist your staff or local rescue professionals. It's also important to remember that the rescue should be kept as simple and safe as possible, putting the fewest workers at risk. In the heat of the moment, potential rescuers might panic and overlook important aspects of their training. To prepare for the potential of a rescue, a thought process needs to be established that reminds every worker of the hierarchy of a rescue. Self-rescue. Self-rescue means climbing or pulling yourself to safety. Assisted self-rescue. This means you're using a ladder brought to you by a coworker. Mechanically aided. A mechanically aided rescue means using a lift or bucket truck to rescue you. Rescue pickoff. A rescue pickoff is a last resort because it requires the most time to accomplish and the most skill to safely perform a rescue. However, rescue as the last component of a fall protection plan is a good problem to have. A rescue situation means the worker was wearing his harness and attached to an anchor, thus making the fall protection plan a success.